So here we have another simple circuit that's driven by two current sources. And so they're asking us to determine what the node voltages are for all the nodes. And then they also want to know what the current is through the 2 ohm resistor. So this is the 2 ohm resistor. So we're looking for the current there. And then the node voltages. So we note that this node right here would just be the reference node. So nothing really to calculate there. We'll call it 0. But then we're left with these two nodes here. So the voltages at those two nodes, and then the current through that 2 ohm resistor. So let's begin that. So the first thing we do is, we define our two nodes. So we have a red node, and we are going to define the voltage there as V1. And then we will have this, what we'll call the blue node, and we will call the voltage there V2. So now let's see if we can determine what our equations are for this. And remember, we're going to go around and calculate the current leaving and entering and leaving each node and set that equal to 0. So let's look at that. So then for V1, first thing we see on this branch is a current source, and we're defining current leaving the node as positive, so that's showing entering the node. So then that will be negative. So we'll start out with a -2. And then moving around here, we see we have this 4 ohm resistor. And so we can write the current through that as V1 over 4. And again, moving down, we have this another 4 ohm resistor. So then that's going to be plus V1 over 4. And then finally, we've got the 2 ohm resistor. And so we'll write that as the difference in the voltages, V1 minus V2, divided by 2. And that's all the nodes going in and out of V1. So then we should be able to set that equal to 0. So that's our first nodal equation. So now we want to come down and look at V2, the blue node. And the first thing we see on that one is also a current source. Now they show this current leaving the node, so that would make it positive. However, it's a little bit tricky. They show the magnitude of it as -4 amps. So that being the case, we'll just write that as -4 then. Okay, -4. All right, so again, coming around here, we will see this 8 ohm resistor right here. And so when we write the equation for that one, that's going to be plus V2 over 8. And then we will have this 8 ohm resistor here. And we will write that as V2 over 8. And finally, we have the purple resistor that goes between our nodes again. So we can write that as the difference in the voltages. So that's V2 minus V1 over 2. And so that's all of the branches going in and out of our node V2. So that being the case, we should be able to set this equal to 0. So these are our two equations. So now what we want to do is do some algebra. So we'll collect like terms and rearrange things just a bit. So when we do that, this equation here will end up becoming V1 minus 1/2 V2, and that's going to equal to 2. And then same thing with this guy. combining like terms and rearranging just a bit, this will be minus 1/2 V1 plus 3/4 V2, and that's going to equal to 4. So 2 equations, 2 unknowns. So again, we'll draw a line here, and so we're going to write these in matrix form. So when we do that, that's going to just be 1 minus 1/2 minus 1/2 and 3/4. So this is our coefficient matrix. And we're multiplying that times V1 and V2. And we set that equal to our answer array, our results array. So with that, again, we just divide, using our scientific calculator, enter that in and divide that into that. And when we do, we come up with the results of V1 is going to equal to 7 volts. And V2 is going to equal to 10 volts. So that's the first part of what they asked us for, was the voltage at these nodes. So this one is 7 volts. So this one is 7 volts, and this one is 10 volts. And then they want us to use that information then to determine what the value of the current is flowing here. So this current in the 2 ohm resistor, so we'll call it I2. So that being the case, we can say that I2 is going to be equal to the difference in the voltages, V1 minus V2, over the ohms of the resistance, so it's 2. And so what we will have then is 7 minus 10 over 2. And that results in a minus 3/2, or we might say that's minus 1.5 amps. Minus 1.5 amps. So again, here's our node voltages, what they asked for. And then our current flowing between the nodes.